Hello guys, welcome to one more video of GATE 2020, and this is question number 20 from the year 2020. The question says a heavily cold worked metal will, and we have four options: yield a coarser recrystalline grain size, possess a lower driving force for recrystallization, have a higher energy barrier for nucleation of recrystallized grains, and recrystallize at lower temperature. So first of all, let us try to understand what is this recrystallization and how different options are actually affecting the recrystallization. So first of all, they are asking about the cold worked metal, okay, heavily cold worked metal and recrystallization. They are trying to relate them. So first of all, let us try to understand what is recrystallization. So recrystallization is nothing but the process where you actually tend to form new strain free grains, okay, new and fine strain free grains, correct? This is the simple definition of recrystallization: formation of a new and a fine strain free grains. But what about the temperature of recrystallization? At what temperature the recrystallization will take place? Let us call it recrystallization, okay, the recrystallization temperature. So basically we have a standard definition explaining this, that the temperature at which at least 50% of the material, okay, is recrystallized in 1 hour. So the time is also important here, okay. So in 1 hour, at what temperature at least half of my material is actually recrystallizing? That is my temperature of recrystallization, okay. And what is the driving force? So we are slowly trying to understand different things. So the first thing is the recrystallization temperature, and the second thing is the driving force. What is the driving force of recrystallization? So here I clearly use the word strain free grains. That means obviously the material which is strained, we want to remove the excess strain energy that is present in the material, which might be coming from cold working, hot working, or any deformation, okay. So more is the energy associated with the system, more is the driving force, because that the excess energy that is possessed by the system has to be reduced down. So what is the driving force? The driving force is nothing but the excess strain energy. Why we are calling strain energy here? Because of the fact that this strain energy is due to deformation, okay. So in the question also, if you see here, what is the deformation technique that they are telling? Cold working, okay. So typically cold working, because you deform at room temperature, okay. So the recrystallized temperature we understood, and the driving forces also we understood. So what happens actually during deformation is simple. So on this deformation, the dislocation density increases, okay. The dislocation density, which is nothing but represented by rho, increases, and as the dislocation density increases, the strain energy increases, okay. So because of that, the driving force also increases, correct? And if the driving force is increased, that means recrystallization can be easier, okay. Why? Because this is reduced by recrystallization, correct? The excess strain energy which is processed by the system has to be reduced by recrystallization. More and more strain energy, easier for the recrystallization to take place, okay. That means more the driving force, easier the process. So here also, higher is the strain energy, which is the driving force, easier would be the recrystallization process. Now here, how do we actually quantify this term easy? That is in terms of my recrystallization temperature, okay. So easier means at less temperature, okay. So maybe I would write in this way over here, more driving force, the recrystallization is easy. That means the temperature at which the recrystallization may happen also will be less. Okay, so what is the driving force here? The cold work. That means if cold working is to a great extent, okay, let me write this way, if cold working is great, then the TR which is required will decrease. Okay, TR decreases. So now coming back to the question, heavily cold worked material, that means the question says that the material is heavily cold worked. That means that the driving force is very high. That means the temperature at which the recrystallization has to be taking place is decreased, is lowered. Okay, so that is your option D, recrystallize at the lower temperature. Okay, and of course here you can see that we have different options. So B option, if you see, possesses a low driving force, which is wrong, right? We know driving force is more for highly cold worked material, so option B is wrong. Also here they are telling about grain size. So typically the initial grain size also matters, okay, because we are aiming for a very fine grain size as an output. Initially, if the grain size is less, then also the temperature can be reduced, TR can be decreased, right? So basically these are nothing but some laws of recrystallization that we call. Higher is the cold working, lower is the recrystallization temperature. Initial grain size is finer, the recrystallization temperature is lowered. Okay, so these are some laws of recrystallization. So if you come to the first question, heavily cold worked metal yield a coarser recrystallized grain size, which is wrong, because in the definition itself we know that after recrystallization we have fine grains. Okay, and higher is the driving force, definitely more and more finer will be the size. And B, as I discussed, it is wrong. And C, have a higher energy barrier for nucleation, which is wrong. If the driving force is high, that means the energy barrier is less. The energy barrier is less, that is why the process is actually taking place easily. Okay, so option D is the correct answer, which is a heavily cold worked material will recrystallize at a lower temperature. I hope you are clear with the concept. Thank you for listening, guys.